Okay, so let's see, we're going to do a bit here on Sheerpower. Sheerpower is an interesting language. It was developed over a period of over 20 years. About 70% of the features of Sheerpower were paid for by clients, business clients, banks and credit card companies, aerospace companies, and so on. So it's very, very feature rich. But what's super cool about it is that you don't have to know a lot in order to do a bunch with it. Sheerpower is what's called an incremental programming language, which means that you can do a whole bunch without having to learn much of the language. And then as you learn more about Sheerpower, you can write code more efficiently. So, let's just start here doing something pretty simple. By default, Sheerpower does not require declaratives for data types. It uses the last character of the symbol name to determine what kind of data it is. And the default kind of data is what's called a real. So if I were to say tax equals 45, that puts into the variable tax value of 45. Tax is assumed to be a real, and a real value means it has both an integer part and a fractional part. And so if I were to print tax like that, that's how you output something. And I would press this little running man guy, which says run the program. There we go, 45, nice and simple. I didn't have to learn how to, do some kind of, int main, blah, blah, blah. And I didn't have to load in some standard libraries and all the rest of it. All of it's built in Sheerpower. Again, it's been years and years and years of development that have caused Sheerpower to have all kinds of really nifty features that are helpful for business. Sheerpower is designed for business applications. Sheerpower is not designed to write compilers. It's not designed to write a programming language itself. So we would not expect to write Sheerpower in Sheerpower. I mean, you can, but that's not what it's designed for. Sheerpower is designed for business applications. We'll do some simple things, first, name. If a variable ends in a $sign, it means it's a string. Again, by default, you can always declare something as a string, but this is the default. Makes it easy at a glance to tell what kind of data type this is. So, print the first name. This little symbol here, by the way, says validate. That says, see if my code's valid. And this runs the entire Sheerpower compiler and checks to see if everything's correct. If I were to make a typo error, like PRNT, see I get an immediate error. If I double click, it highlights where the problem is. And we'll run this. The 45 from tax, and Sally from printing the first name. So again, very simple. Sheerpower also has other data types. It has a Boolean data type, which is, is taxable. Question mark at the end means it's a Boolean data type. False. So now I can say if it is taxable, then print yes, taxable rate is tax. So this says, of course, is taxable is a Boolean, so it's true. Well, it's false here. If it is taxable, then yes, taxable rate is whatever. If I run this, it's just going to have the 45 for here, and it's going to have Sally for here. It's not taxable, so it's not going to print this out. If I wanted to print that out, true. Run it again. Yes, taxable rate is 45. Again, really simple, easy to understand, easy to read, easy to work with. We also support integer data types. Age equal to 56, let's say. print age, and we run it, and age is 56. Okay, so simple enough. Personally, I tend never to use the integer data type. I don't find it to be particularly helpful in most cases. Address space, what people call memory address space, is not a problem anymore. It used to be a long time ago, not anymore. You can write huge programs. So making something an integer for saving address space, saving memory, isn't really a good reason. And of course, real data types are handy in that they support both an integer part and a fractional part. So I could say tax equal 45.6789, for instance. Now when I run this, it says tax rate is 45.6789 right here. So again, really simple. If I want to make a loop, I start with a do at the top, a loop at the bottom. I might say something like, let's go up here. Counter, counter is equal to 0. Great. Counter plus plus, that adds 1 to the counter. Print counter, counter greater than or equal to, let's say 10, then exit do. So that's pretty clear what that does. Have a do here, loop here, exit do, exits out of this loop. We'll have it say like print done. Okay, and let's get rid of some of this. We just drop that out. Good. Run it. There's our counter going all the way to 10. And now we're done. It says if counter greater than or equal to 10, then exit do. So if I were to print the counter, see how are we doing on it, it's a 10. Not a surprise because it got to 10 and now it exits. So it's really easy. We can do lots of cool things with these do loop things, by the way. We can do while statements. We could say loop while counter is less than or equal is less than 10. Now we run that, and you can see we've counted to 10. The while statement says keep doing this loop thing as long as while counter is less than 10. So that's pretty simple. You can also put these, the while could have been on the do as well. Do while counter less than 10. And we print that out, and you see same effect. Now what's interesting is that we can put this while statement in other places. We could actually say print counter, and then we could say while counter less than 10. And that works too. So the while statement, and we have an until statement as well. The while and untils can be anywhere you want inside this do loop. So it makes it very versatile. You can also combine while statements with additional while statements, and you can also have additional until statements inside this do in the loop. The one I tend to use a lot when I'm writing things is what I call a single loop, which is a do and then an end do. And an end do just says do this once. So if I were to say counter plus plus, print counter, guess what that does? Adds 1 to the counter, prints it out, and then we're done. That's it. Cheap. Run it, did it exactly once. That's an end do, and you might think, well, what's the point of a loop that doesn't loop, right? A do and then end do. The point is that you can do some clever things. You could say something such as, if counter is less than 10, then repeat do. So I can say, even though this is usually just going to go through here once, if it's less than 10, I want to do it again. And there we go. Once again, we're counting to 10 using yet another method. So repeat do is very, very helpful. I use it a lot when I'm asking for input from a user. And let's say they didn't bother to give me any input. So let's learn a new statement. We'll do a line of input saying I'll just say name. Okay, so I'm going to ask for a line of input. I'm going to prompt the user for a name, and then whatever they type in, I'm going to store the result of that in this thing called the name, and I'm going to say print hello, comma, the name. Guess what that does? Well, we start here, ask for the name, store it into this variable called the name. It ends with a $, which means it's a string. Print hello, there's a semicolon here, and then the name, that's going to say hello, you know, Sally or Fred or whatever, and then it's going to be done with the loop. Okay, so that's kind of easy to follow, Sally. Hello, Sally. Well, what if what we want to do is that if they enter in nothing, we want to just get out. We don't want to say hello because they didn't give us their name. We just want to get out. So we would say if the name is equal to nothing, then exit do. So if they don't give us anything, then exit do. Name, and we press the enter key all by itself, and it says done. You'll notice it did not say hello in the name. Now let's say we have another rule here that says that we want the name to be, let's say we want the name to be at least 1 character long. Otherwise, we're going to say it's too short. So we'll say if the length of the name, okay, is less than or equal to 1, then let's print, this would be a multi-line if statement, by the way. Print the name is too short. The name. And then guess what we're going to do? We want to go back to this line input statement because the name they gave was too short. So what do? We repeat do and if. And now you'll notice I'm going to put a little bit of blank lines here just to make it look prettier. Now it's easy to see this condition. And we'll go like this. So we run this code. Name, Sally. Yeah, that worked really well. Let's run it again. Name is A. The name is too short, A. It's asking for the name again. You can see here it's really simple how this works. So one of the hallmarks of Sheerpower is that it's really, really easy to program in. It means that writing code is very, very fast. You get huge efficiencies on programmers writing code. They can write it very, very quickly. They can debug it very quickly. Sheerpower compiles down into byte-code, just like Java does. Same sort of idea, except Sheerpower's bytes of byte-code are very, very powerful. We have like a byte that stands for sort this database. I mean, that's a byte. So we have very powerful bytes in our bytecode. We generate all of it before the program starts running, but we generate it really, really fast. A typical Sheerpower program compiles at the rate of way over 200,000 lines of code per second. 200,000 lines of code per second. That's super, super fast. It means that every piece of code you write is basically instantaneously compiled. One of our clients has a program that's over 500,000 lines of code, and they have over 350 include statements to include various modules. With all of those include files, compiles in less than 3 seconds. So everything is instant with Sheerpower. It's a lot of fun to program in because it's instant gratification. It's a lot of fun to program in because it's an incremental learning of the language. You can start really, really simple like we've done here, and you can then expand into doing all kinds of cool things with routines and lots of things like that. So it's really fun. Sheerpower has private routines, it has global routines, it has local routines, it has scoped routines, it has lots and lots of ways to segment your code. It has modules, it has libraries, it can call DLLs. So it has all the nifty things that you need to write professional business code. Okay, and that's the end of this short lesson.